Also, notes, I didn't do them. I asked everybody at church yesterday. They didn't do them. Nobody could do them. Except for Luke, he's holding out his girlfriend. Right? I sent people notes.
Anywhere for break, or did you just stay?
Yeah, that's not how tomorrow's problem. Also, we have a quiz.
It's not really basic because you're in number 12. There are a couple handouts, and you'll need a textbook today if you didn't think to grab those. Three, 1, 2, 3, 1, 2. Kerrigan did make it. Mathis will be here today.
Good morning, FHS. Today is Wednesday, January 3rd, 2024. Would you please join me in a minute of silence?
Did you call this in, or did I need?
I mean, if there's a sub, they should be here, and if it's her, I didn't call anybody.
I haven't called anybody either.
I expect that she'll be here in a minute, but
Okay.
I don't know.
Please stand if you are able and join me in the pledge. Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
All right, welcome back. Hope you all had a nice, restful break. I wanted to start off this morning by just giving you kind of a quick little overview of what we're looking at this semester. Second semester for this class is quite a bit different from first semester. Now, not everybody, but most people tend to think that second semester is a little bit easier. We're, for the most part, done with trigonometry. And second semester, we focus a lot more on algebra. So, of all of the trig stuff you learned last semester, the only one that you are still going to be on the hook for is unit circle. So, that one is still fair game. But, again, we spend most of this semester reviewing some algebra topics. So the first few days here we're going to do something called law of sines and law of cosines, which is kind of trig-ish, but really this used to be taught in geometry, so it's not a hard concept. And this doesn't help you with calculus at all, which is what the purpose of this course is, pre-calculus. But we do like to give a couple days towards the law of sines and law of cosines, because this is one of those topics that often shows up on the ACT, like almost every other time at this point, and it's not too difficult. So today we'll do law of sines, next class we'll do law of cosines, we'll wrap it up and then quiz and move on for that. But again, that's really just kind of for you. But so we only spend a few classes there. Then we'll spend a couple weeks on a topic called limits, which is really the first calculus topic that you would learn, and most of that is algebra, but that's a little bit different. Then we'll spend a good number of weeks on logarithms and exponentials. We know that you saw those in Algebra 2, but you don't know them near well enough for calculus or college algebra or pretty much anything higher than this. So we will do a deep dive on those to make sure you really understand them well. And then we'll spend a little bit of time on linear functions, quadratic, piecewise functions, a lot of stuff that you guys saw in Algebra 2. A couple weeks on rational functions, where you have like wholes, vertical asymptotes. Again, another topic from Algebra 2. And then we're just about out of time for this semester. So, again, most people think it's easier. I think the class average is usually about 4 or 5% higher than first semester, but you know, algebra is not easier for everybody. Some people prefer first semester. So, but I tend to say that if you put in the same effort you put in the first semester, you can expect about 5% higher overall in the class. All right, so let's go ahead and talk about the law of sines. It doesn't take but just a minute here. So one of your handouts, you can see we're going to continue on with our binding number. So we ended up with 56 before we left. So this will be 57. Just to be clear, I think it is a good idea for you to keep your binder intact from first semester, but you don't have to bring it to class every day. In fact, I would take it out of your binder or just leave that binder at home, put it somewhere safe. Maybe someday you want to look back at it. Maybe someday you need to look back at some of that trig stuff, and that's great. But I won't ask for anything from first semester. So that stuff can be put away, and you don't have to carry it around all semester. But I do like the numbering to continue. So 57, we're going to do the quick set of notes there. 58 is a book assignment, but it's got a couple vocab check questions. And then there's like 9 or 10 practice questions pretty quick. So I will want that one turned in today. There's no reason you won't have that finished. And then once you're finished with that, you can start the worksheet, which is also pretty quick. But if you need to finish that one up for homework, then you can. Okay, so the main thing about law of sines and law of cosines and how it's different than what we did last semester is last semester we did right triangle trig. So things like SOHCAHTOA, Pythagorean theorem, all great stuff, but they only work if it's a right triangle. Law of sines and law of cosines works for any kind of triangle, whether it's a right triangle or not. So the law of sines formula looks like either this or this. These are saying the same things. If you took the reciprocal of this and the reciprocal of this and the reciprocal of this, it would look like this. And it basically just says that if you took a side length of a triangle divided by the sine of his opposite angle, it will be equal to a different side length divided by the sine of his opposite angle, and equal to the third side length equal to, or divided by the sine of its opposite angle. So very easy formula to memorize, but even in this section, we don't even make you memorize these formulas. In fact, on our quiz, we will provide the formulas for you, because again, your success in these couple days doesn't really carry on to anything. It's really for your benefit in the ACT. So we'll provide those for you, and I'll show you how to use them in just a second. But basically, you plug in 3 numbers and then solve for something else. We will ask you, and so you do need to know when you can use law of sines. So sometimes if you're not sure if you have enough information, you can just plug the numbers into the formula and see if you have enough to solve for something. But this is probably the way that you want to memorize this. These two mean that you have 2 angles and 1 side length. So if you know any 2 angle sizes and 1 side length, you can use law of sines. And then sometimes this one works. This one has 2 side lengths and 1 angle measure. Okay, and then just to make sure that you know the difference between angle side angle and angle angle side, in case you don't remember that from geometry. Let's pick up a couple here. Angle side angle is when you know 2 angles, like maybe this is 30 and this is 40, and the side that you know, this is called an included side, and you need to write this on your paper because we do ask you about that on the quiz. Just like the S is trapped between the 2 A's, the side length that you know the length of has to be trapped between the 2 angles. Versus angle, angle, side, you would know 2 angles, and then S is not in between the 2 A's, so the side length that you know can't be the included side. It can't be the side that's in between those 2. It has to be one of the other 2. And then side-side angle is when you know 2 sides and an angle that's not in between those, not the included angle. Now, to be fair, if you guys ever take a college trig class, you probably will do law of sines and law of cosines very briefly, and they will make you do something called the ambiguous case. This is considered the ambiguous case. We used to do that until like 2 years ago, I think. We'd make students do that. But it didn't add an extra day to this unit, the short little unit. And again, we do this for you, for the ACT, and the ACT doesn't ask about the ambiguous case. So it seemed kind of unnecessary. But some of this should sound familiar because back in geometry, there were some ways that you could prove triangle congruence. If 2 triangles had the same 3 side lengths, you know those triangles were congruent, meaning they're the same size and shape. If they had 2 angles the same and the side length that was not included, you're guaranteed that they'll be congruent. So that's where you've probably heard of these 2 and maybe not side-side angle, because this one only sometimes works. Depending on how big those 2 sides are and depending on how big the angle is given to you, you could either get 1 triangle out of those lengths, sometimes 2 triangles out of those lengths, and sometimes no triangles out of those lengths. But that's what's referred to as the ambiguous case. And if you are interested in the ambiguous case, I did link a video on the back page. We will put a bonus question on the quiz on that, so if you really want to go and learn about it, then you could potentially pick up a couple more points on our quiz. But again, it's not something we're going to spend time on. Okay, so on the next page, I've got 2 examples already typed out, and I've got 2 examples that I want us to put pencil to paper on. And then you'll basically have seen all you need to know about law of sines, and you can practice plugging it in and solving. So, example 1, trying to find a side length. So notice there's a couple angles here, there's a side length here, and there's a side length that you're trying to find. So this would be an angle, and then as you walk around the figure, there's another angle, and then there's a side. So this is angle, angle, side, which will always work for law of sines. again, you will have to memorize this. We do expect you to know when you can use each one. So they called, I don't know, maybe they called this angle A, which makes this side A. Maybe they called this angle B, which makes this side B. And you can see they did sine of angle A divided by the length of A and set it equal to the sine of angle B over the length of side B. And all they did was plug in angle A, angle B, side A, and side B. Okay, and then they're solving. I don't know that I'd really solve it this way, but you can cross multiply. So you get 10 times the sine of 55 and x times the sine of 48. Undo the timesing of sine by 48 by dividing both sides by the sine of 48. And then assuming your calculator is in degree mode, that's what you would type in your calculator, and you now know the length of that side. So basically, you plug in A, B, C, angle A, angle B, angle C into the formula, cross multiply, and solve. And you can either find a side length like this, or you can find an angle like example 2. So this one, this is a side, then a side, then an angle. So this is the one that sometimes works. You don't have to worry about if there's no triangles or 2 triangles, because we're not going to do that to you unless you want to watch that video and aim for the bonus question. But same idea. If maybe this is angle A, opposite that would be side A. If this was angle B, opposite that would be side B. And then they just plug that stuff into the formula. So this is like sine of angle B over side B, sine of angle A over side A. Gives you a little statement where you have only one unknown. Looks like they multiplied both sides by 12 so that you get to sine x equals this stuff. They changed this to a decimal, but the part that you need to focus on here, and I know we talked about this last semester, but you know it's been a couple weeks that you probably have not thought about this at all. But if sine x equals this, to find out what x equals, you have to do inverse sine of that. Inverse sine is how you get an angle. This is just a ratio. This is asking the calculator, if the opposite side is this big and the hypotenuse is that big, how big does the angle have to be? And then it can spit that out. Okay, so I want us to go over just these last 2 here, and then I've got one area formula for you to go to see, and then you'll already be ready to practice. That's pretty much all it is, just to make sure that you got it down. Alright, so I don't really feel like a picture is necessary most of the time, but if a picture helps you, then go for it. Angle A, side A, angle B, and we're trying to find side B. So, again, you don't have to memorize the law of sines formula for us, but it's pretty hard not to memorize. It's so easy to learn. Basically says, part of it says A over the sine of A is equal to B over the sine of B. So if A is 10, make that substitution. If angle A is 48, make that substitution. If angle B is 55, and we're almost done already. Undo times, or undo divide with times. It looks like B is exactly this, and from what I've seen and heard, I believe this is what the ACT does. It leaves the answer choices looking like this so that you don't even have to have a calculator. You just have to match up which one it is. But for us, we are going to go ahead and throw that in the calculator. Of course, make sure you put it in as a fraction or put in some parentheses so that your calculator computes that the way you expect it to. And I guess the last piece of advice I give to you is make sure that this number is realistic. If opposite 48 degrees has a side length of 10, then opposite 55 degrees should be bigger than 10. So 11 something sounds reasonable to me. Okay, any questions about the first example? This is the only one that I'm showing you on how to find the side length. Okay, I didn't verbalize this, but I did it. So let me say why I did this one. And you may disagree after a few questions, but this is just two different ways to look at these. I tend to use this one if I'm trying to find a side length, side A, side B, or side C, because if that's what I'm solving for, I kind of like it to be in the numerator already. Whereas if I'm trying to solve for an angle measure, I tend to start with one of these so that the thing I'm solving for is in the numerator. Again, it's not critical that you do that, but I think it just works out a little bit easier, so that's what I will be doing. Okay, then let's look at one where we need to find an angle. So same thing, I really don't think you need a picture, but feel free to make a picture on the first few if you want to. We know side A, angle A, and side B, and this time we want to find angle B. So one form of the law of sines formula says that we can take the sine of angle A over the length of A and set that equal to the sine of angle B over the length of B. Just plug in the things that you know. And then be able to solve for the things that you don't know. So we can multiply both sides by 2. Feel free to put this in your calculator if you want to, but this is going to be a number between -1 and 1. This isn't how big angle B is. This is how big the sine of angle B is. So make sure that you remember, if you're finding an angle, you're going to have to switch it from sine to inverse sine. But assuming your calculator's in degree mode and you enter it in correctly, which is part of why you need to practice this, your calculator does not always do it the way you expect it to with fractions and such. This is about 5.89 degrees. So pretty small angle, but again, that seems realistic to me because its opposite side is really small, at least in comparison to the other. If it's only 46 degrees opposite 14 degrees, the angle opposite 2 would have to be quite a bit smaller, so just under 6. This is the part you need to emphasize in your notes though, going from here to here. I know we did it last semester, but again, just not something you do as much. All right, any questions about that one? Okay, again, completely optional if you want to watch this video. I think it's like 20 minutes, I want to say, but it shows you what the ambiguous case is and how you can work through it. And if you want to go through all that, again, you'll have a chance at a bonus question on our quiz. But the last thing that we want you to get out of section 6.1, we will do something similar in section 6.2. 6.2 is law of cosines and an area formula, whereas 6.1 was the law of sines and an area formula. So let me go ahead and just tell you what the area formulas are that you need to know, and I'll show you where they're coming from. So area of a triangle, the formula that you should be very familiar with is, of course, 1/2 base times height. But depending on the triangle, I'm going to just try to make maybe one example here. The base can be any side. Typically, y'all say the base is the thing at the bottom, but you can turn the shape and change what's on the bottom. So the base could be A, B, or C. Okay, so I said I would just go ahead and tell you what they were first and then tell you where they came from. So it could be 1/2 AB times the sine of C. It could be 1/2 A C sine of B, or the last possibility would be BC sine of A. And I think this picture is what's going to match up for that. If you try to do area of a triangle formula on this so you can see where they're coming from, in this problem I would probably call the base B just because it's on the bottom. Base is B, base is B. But the height is the distance perpendicular to the opposite side. So in geometry courses, your teachers probably just said, here's the height, go with it. But we have a little bit more information to work with this. Like we saw last semester, you could look from, if this is angle C, this would be side C. You could focus on this right triangle and do a SOHCAHTOA equation. You could say the sine of this angle is equal to opposite over hypotenuse. So if you have a triangle oriented this way where the base is B, your height, instead of calling it H, could be C times the sine of A. This is why I did this in red. The height could be C times the sine of A if it's oriented this way. But you could change where A, B, and C are, and the height could maybe be C times the sine of B, or you could change them to the third possibility, and the height could be B times the sine of C. So this is just a really nice way if you have side angle side. So if you have two side lengths and the angle trapped in between those, it's a really easy way to compute area. So it's not that you couldn't derive this and figure out the height with right triangle trig like we did last semester, but it's also not necessary. And I have also seen this on the ACT. So we will practice that a few times as well. Okay, make sure that you have that down, please. And then let's switch over to the book assignment. Again, it's pretty short. 4 vocab, 9 book questions like the ones I just did with you. So, blank piece of paper, copy down the assignment, jump into that, and I will help out here in just a bit. You will need a calculator, and you'll need to make sure your calculator is in degree mode, or you're going to be frustrated for a bit. Again, I said this at the start of class, but I will ask that you turn in the notes 57 and the book assignment 58 before you leave today. Just because it's so short, there's no reason for you to not finish that. And I can start putting those grades in. But even after you finish the book work, you need to also do the worksheet. So if you have time to do that in class, that's great. No homework, but if you need to finish it up outside of class, that's okay too. as always, give each question a good effort. Don't give up instantly. But also just skip ahead if you're not sure what it's asking or how to start it or why your answer's not matching up. And of course, I will help with whatever you need. Okay. Any of the vocab check I can help with? 1, 2, 3, or 4, or maybe question number 5. Any of those you'd like me to go over with you? I'm sorry, which one?
Number 3.
Number 3. So really what they're aiming for on question 3 is they're getting at when can you use the law of signs. So these were the 3 cases I told you that you could use, and they're focused, since this one only works sometimes, they're focused on these 2. So both of these have in common that you need to know 2 angle measures and 1 side length. So 2 angle measures and 1 side length will always allow you to use law of sines. Okay, other vocab check or question number 5. Okay, then go ahead and keep on going, and I'll offer some help here again in just a bit. checking in again. So any of the vocab check, maybe question 5, 8, or 11. Any of those you've tried yet that you'd like me to go over? Number 8, okay. Okay, so the directions in number 8 ask us to solve this triangle, and solve means find everything. So I still don't know angle B, so that's one of the things we need to look for. I don't know how big side A is, and I don't know how big side C is. So they're expecting 3 answers here. I guess if you, well, you could, as much as you wanted to, I know this section is about law of sines, and so you know that you're supposed to use that. But if you don't notice this right away, you can do what I'm about to do, and it at least gives you a hint. If you just write out the law of sines, and you start plugging in the stuff that you know, the stuff that's given to you, you don't have enough information to solve for anything else yet. So again, when we use law of sines, we only look at 2 of these 3, so we usually ignore a piece of it. But I can't solve this for side A or angle B because I can't solve an equation that has 2 variables. So before you do anything else, you really have to figure out this guy, angle C. So nothing to do with law of sines, but if you know 2 angles of a triangle, assuming you're talking about a flat space, triangle will always add up to 180, so we can just subtract those 2 from 180 and figure out the missing angle is 41 degrees. Oh, wait. Okay, and now that I know that, I can solve for A or C. You can see that I have the law of sines written out here. So I'm going to focus on this part for just a second to solve for side A. So we could cross multiply. A times the sine of 41 degrees is equal to 5.5 sine of 16 degrees. I do multiplying by the sine of 41 degrees by dividing by the sine of 41 degrees. Here's your exact answer. Again, this is what I would suspect it looks like on the ACT. I don't think they see any value of you typing that in the calculator, but you guys need to practice that because that's how you will be assessed. And again, sometimes you guys don't put this in the calculator correctly. A lot of times you guys will do it like this. You will say 5.5 sine of 16 divided by the sine of, what was it, 44, 41. I know why you want to type it in that way, but this is, actually that is fine. Sometimes it's not fine. In general, as a good rule of thumb, it's a good idea to just put parentheses around your numerator and parentheses around your denominator. Sure, sometimes you don't need it, but sometimes you do, depending on what you do. Or you can do alpha y equals option 1, and then when you type it in, it'll look like a big fraction, and that's putting the parentheses in there for you. So anyway, so if I do that, that is about 2.31. It was about 2.31. This question asked me to round to 2 decimal places instead of 3, so I don't know why they did that, but that's okay. Okay, and now I'm going to use this part of the law of sines to solve for side C, because if I'm looking at just this part of the equation, C is the only variable that's missing. So same thing, I could cross multiply, if you want to think of it that way. C times the sine of 41 is equal to 5.5 times the sine of 123. Undo times with divide. This is what your exact answer would look like. And if you type that in the calculator correctly, again, this one's pretty hard to not put in correctly, but if I just round to 2 decimal places like it said, says C should be about 7.03. Of course, if you feel like you're typing that in correctly and you're getting a wildly different number, you might be in radian mode instead of degree mode. This is 123 degrees, so your calculator has to be in degree mode. So C is about 7.03, and I guess the last thing that I think is worth my time here, since that question took me a couple minutes, if I update my picture with all my new information, I may be able to catch some mistakes by just thinking about what side's supposed to be biggest and what side's supposed to be smallest. Biggest side is supposed to be opposite biggest angle, that's true. Smallest side is supposed to be opposite smallest angle. If that's true, then the medium-sized side will be opposite the medium-sized angle. It doesn't guarantee that our answer is right, but if that stuff was not true, it would guarantee something was wrong. So, okay, any specific follow-up to question 8? Okay. See which ones you've got. Okay, then how about the vocab check? Questions 5, 11, or 37? Any of those questions ready to go?
37.
Sure. These questions won't be too bad because if you read the directions here, it says find the area. So this is what we did at the very end of your notes. So if you have side angle side, I know this is a completely new area formula to you, but it's just so easy to use it. It's a shame for you guys not to see it. Basically, as long as you have any two sides, like side B and side C, and the included angle, this is one way to find area using side angle side, and I picked out this one because this question gives us that exact information. It tells me how big side B is, side C is, and how big angle A is. So in your calculator, oops, B times C times the sine of A is almost correct, and I actually have a mistake here. And my mistake that I just made is very likely to happen to you guys as well. Why is this formula not correct? Right, it needs the 1/2. Just like area of a triangle is 1/2 base times height. In this question, the base was B. The height was found with the SOHCAHTOA equation. Again, you shouldn't have to do that. Just know the pattern of those formulas, and then you just plug in what it says, and you're done. But forgetting that 1/2 is a pretty common problem. And since it's an area, the units would be squared. 22.117. Okay, I'll leave this up and give you a few more minutes to try a few more before I ask for more questions. But again, 37, 39, and 41. All those should be pretty quick because they're just area formulas. Also, just in case you haven't heard, this is an A week, so I will see you on Friday. This week is obviously a short week since we're starting on a Wednesday. Next week will be a full week, but then the week after that you have Monday off, so you get a little bit of a ease into second semester.
Johnson.
Yep.
I forgot what like one quotation means. I know it means like minutes or hours, but
Yeah, so you got 83 full degrees. One tick mark means minutes, and
Okay.
a minute is a 60th of a degree. So just change that to a decimal and then work with it.
Alright, thank you.
Yeah.
Well, this is degrees and minutes. So this is like 103 full degrees. So a minute is a 60th of a degree. So that angle is not 103, it's about 103.25. So if that angle is a bigger, it's a little bit bigger.
Okay, give you a chance to speak up if you have found something else. I don't know, anything up through maybe number 47? Or actually just anything, I guess, because there's only one more after that. Question 11? Sure. Okay, so 11 does not make a triangle picture for me, but of course if that helps you, you can do that. It still falls into the directions of solve the triangle, which means find all the side lengths and all the angle measures. And question 11, angle C is given to you. Side C is given to you, which is good. Law of sines, you're going to need a side length and the angle opposite that, so that's perfect. And then they also tell me that angle A is 83 degrees and 20 minutes. So again, this degrees, minutes, and seconds carries over from last semester, so you have to remember that this is 83 full degrees and a minute is a 60th of a degree. So in my calculator, 83 plus 23 over 6 or 20 over 60 is about 83.3 repeating. And I'm actually going to store that in my calculator so I don't have to keep up with all those decimals. Don't round to 0.3 and just use 0.3 the rest of the question, because then these answers are going to be just a tiny bit off. Okay, so that's the stuff that's given to me. And this is not the only question with degrees, minutes, and seconds. So I totally understand why you may have forgotten about that from last semester, but that is something that you do need to remember. So add that to your notes if you need to. So if I'm thinking about law of sines, I could say side A divided by angle A is equal to side C over sine of angle C. That gives me an equation that only has angle or side A missing. Multiply both sides by the sine of 83.3 repeating. Let the calculator do the rest of the work. Again, I can do this a little bit quicker since I stored this in for angle A and I didn't round this. But this guy comes out to be about 22.055. Okay, and as much as I may want to use law of sines again yet, I can't. You can't find side B in law of sines without its opposite angle. You can't find angle B with law of sines without its opposite side. So I've got to find one of these before I can find the other. Well, right here, if I've got two angles of a triangle, as always, we can just subtract those. From 180. And I will store that in for angle B, so it's not rounded, but that comes out to be about 42.06 repeating. And now that I have this, I can use law of sines one more time. I could say side B divided by the sine of his opposite angle is equal to A over the sine of A or C over the sine of C, whichever you think is easier. I'm going to stay away from A personally, just because I might have made a mistake here and because the decimal's a little messier to work with. I'm going to use C over sine of C. So side C divided by the sine of angle C gives me an equation to solve for B. Looks like my answer for B is going to be 18.1 times the sine of angle A divided by the sine of angle C. And again, you either need to keep up with all of those decimals on the long decimal parts, hold up, that can't be right. Oh no, ignore that. I did not enter it in correctly. I used the wrong number there. 14.877. 14.877. Okay. I think these numbers look good now. So again, I had to use law of sines once to find one of the values, law of sines to find the last value, but I also had to find one of those angles in between, so subtracting those from 180. Again, any question where you're going to have to spend several minutes on it like this, I think it's a big mistake if you don't spend 5 more seconds. Make sure that your biggest side is opposite your biggest angle. Make sure your smallest side is opposite your smallest angle, because you will know something's wrong, and that's almost what I just did. That's how I knew something was off. If you check those two, the middle one should be fine. Okay, I don't know whose question that was, but is there anything specific about 11 while it's still up there for anybody? Okay, then, so we did 8 and 11 and 37. So how about 39, 41, 45, 47, or 48? Yeah.
Maybe 47.
Sure. 47 is a great one to ask too, because there's something on here that you may not think about. It's not hard, it's just that you guys don't often think about it. You said 47, right? Okay. Okay, so 47, I don't know, you guys may remember last semester there was a couple questions, 1 or 2 of them are even specifically about fires, where we set up 2 equations, solve those equations with system of equations, and it was really nasty, messy algebra. And I think we did it in the book assignment, and I told you didn't have to worry about it studying it for your test or anything, because in January we'd learn law of sines and law of cosines, and we're not restricted to just right triangles now. Right triangles show up all the time, so that's great. Pythagorean theorem, SOHCAHTOA is all wonderful. But a lot of times in the real world you don't have right angles, and you don't want to dissect everything into right angles. But this question wants us to figure out how far away this station is from the fire and how far away this station is from the fire. Okay, so I guess the easy part would be labeling this angle. If this whole thing is 80 and this much of it's 65, this much of it would need to be 15. So again, I know this section is about law of sines, so I know law of sines is going to help me, so I can kind of pair these two up. I can pair up a side divided by the sine of his opposite angle. And if I can find another side length and his opposite angle, that will give me an equation that I could solve for y. But from here, you're going to get stuck pretty early because you just don't have enough angle information. So here's the thing that we did last semester that you may not have thought of, but you will need this for question 47 and 48. If you read the question and not just look at the picture, you know these angles came from bearings. This is a north-south line, and this is a north-south line, which means these two by default are parallel. This line acts as like a transversal. So this angle in the top left alternates with the one in the bottom right. So if this is 80, you could get that that's 80. That's just one option. Again, remember I always did the alternate interior angles. Inside the parallel lines, alternating. Top left with bottom right. And then if you have even just one more angle like this, you'll probably be fine, because these two make half of a circle, so they have to add up to 180, so this must be 100. These three make up angles of a triangle, so together they have to add up to 180, so this would have to be 65. And then if you look at the big triangle, one angle is 15, the other angle is 65 plus 70, which leaves the last angle to be 30. So all of this one was 135. Okay, so now it should kind of fall into place here, because now I've got an angle and his opposite side, so I could say y divided by the sine of 15 is equal to 30 kilometers over the sine of 30 degrees. So y is going to be 30 sine of 15 divided by the sine of 30, which is about 15.529. And technically they want x as well, but again, the hard work is behind us here. If I want to know x, I need to divide it by the sine of his opposite angle and set it equal to some other length that I know, like 30 divided by the sine of his opposite angle. So it looks like x will be 30 sine of 135 divided by the sine of 30, or 42.426. Again, my picture is a little busy here, but biggest side is opposite biggest angle, smallest side is opposite smallest angle, so I don't have any immediate concerns. But this highlighted part, until you get more angle information, you can't use the law of sines. So parallel lines, use one of those angle relationships that you learned from geometry. Alternate interior angles will always work, so that's why I just do that one for consistency. Okay, and I'm 99% sure you need to do something similar to that for 48 as well. Okay, and I am going to adjust our agenda just a bit here. You guys still have 13 minutes, so I think you probably should still be able to finish the book assignment while you're here because it's so short in questions. But if you can't finish it in class, I won't penalize you. Again, I wanted you to turn that in. If you can't quite finish before the end of class, just make sure that you do it before next class. I do want both those turned into Google Classroom. So, and if you don't get to 48 while you're still here, I do have that one worked out on the website, so you can get some help on that one outside of class. But the notes need to be turned in. The book assignment, please turn it in if you have it finished. If you just didn't have time, make sure you have it finished before Friday. I also want you to do the worksheet for homework, but you don't have to have that one turned in by Friday. I will ask for that one at a later date.